And thanks so much for everyone that has joined this morning to learn about engineering, specifically at John Deere Horicon Works. And I want to introduce our guests and presenters today. First, we've got Bill Holes, a senior quality engineer at John Deere, Gary Walsh, supply chain integration, Chris Bailey, manufacturing engineer supervisor, and Jeff Kennedy, labor relations manager. Thanks so much, all of you, for being with us here and talking about your careers and what it's like at John Deere and what engineering is all about.
Well, I'd like to just take a moment here to thank Mad Rep and the Inspire program for everything they do for the state and for putting together this meeting for us to get together today. My name is Jeff Kennedy. I'm the Labor Relations Manager, essentially Human Resource Manager for our Horicon Works location, located in Horicon. We're about an hour northwest of Milwaukee, about 45 minutes northeast of Madison. So we're kind of south central of the state. So what we're going to be going over today is I'm going to talk a little bit about our company as a whole, just to highlight what we do here in Horicon. And then I'm going to pass it on to a few of my wonderful team members. Chris Bailey, manufacturing engineer, Bill Holtz, senior quality engineer, and Gary Walsh, supply chain integration manager. And essentially, we want to take some time this morning to talk about engineering. So we're going to go over what is an engineer, what does an engineer do, and all the different types of engineers. And then we should have a little bit of time to walk through a relatively simple but complex problem-solving case and kind of how to approach it from an engineering standpoint. So hopefully everyone's able to get a good understanding of what we do and what it means to be an engineer. I'll take a minute here just to talk about Horicon Works. Again, we're located north of Madison and Milwaukee in a town that's probably right around 4,000 people, fairly small town. Out of that, we have about 1,300 employees that work in two main facilities in our small town, and we call that Horicon Works. Here we do a number of different items for John Deere. We have some welding, assembly, paint. This is a picture of our downtown plant, fully loaded with a parking lot full. We also have a second facility that's located about a mile west, which is some of our newer manufacturing, but that also includes some of our what we call stamping press operation. It's really heavy metal work, as well as some of our final assembly on our products. So what do we build here? That's what some people ask. So hopefully some of these items here everyone has seen, whether it's at home or as they're driving through their neighborhoods. But here in Horicon Works right now, we build premium riding lawn equipment for John Deere. So if you've gone to a dealership and you've seen riding lawn mowers, as you can see in the pictures here, that's what we're currently producing out of Horicon Works. Along with that, we also produce our Gator products. So our Gator products are the side-by-sides, if you see kind of on the bottom right-hand side there, and there's a number of different models. So these have a lot of uses, from recreation to commercial to farmers using these out in their field. Really fun to drive, really fun to make. We produce those actually here in our Horicon Works facilities. Along with that, we also have a number of what I'd call smaller products that we build here, and a lot of those are attachments on other John Deere units. Those are things such as the decks that you see in the middle, snow blowers, plows, some turf care equipment for golf courses. So we produce a lot of items here, and we're very proud to be producing for John Deere, which is a high quality item for customers all across the world. So that's a little bit about what we do here. What I'm going to do is pass it on to my teammates to go over what is an engineer and talk about how the different kind of engineering and what the engineers do at John Deere.
Thanks, Jeff. I'm Gary Walsh. As Jeff mentioned, I'm from the supply chain integration group here at Horicon. And what that means is we're the group that really buys the parts, bring the parts into the factory to assemble all the products that Jeff told you about. We do make some components here at Horicon, mostly things that we stamp out of metal and then weld into metal objects. But we also buy a lot of product from all over Wisconsin, all over the United States, and all over the world. And why is supply chain part of an engineering presentation? Well, actually about half of the people in our supply chain group at Horicon actually came from different engineering backgrounds. It's very helpful to have an engineering background in our function because we interact with engineers quite a bit as we're talking about new designs, and we also need to be able to understand the processes and dimensioning and prints and so forth as we're working with our suppliers to bring those parts in. So first of all, what is an engineer? Some of the things on this screen talk about some of the characteristics of an engineer and some of the things that they do. First of all, they're curious people because they want to take problems and solve them. We'll talk a little bit about that in the next slides as we go. But as we go through this presentation, we're going to see a lot of problems that the world is going to be presenting us in the near future. And then Chris is going to talk about the problems at John Deere specifically. But if you're somebody who's curious about the world, curious about how things work, or you're interested in science and math, of course, you might be somebody that's interested in looking into engineering. So what is an engineer? So scientists study the world as it is, but engineers create the world that has never been. So in other words, we look at problems and we look for ways to solve them. In the end, engineers are people that turn concepts into reality and really solve problems through taking ideas and actually turning them into a solution. So let's talk about what kind of problems the world is going to be presenting engineers in the future. On the left, you see a chart that shows population growth going all the way back to the 1700s, but then looking into the future out to 2050 as well. And if you look at where we are today, the world has about 8 million people now. And in the next 20 years, that population is going to grow over 9 million or 9 billion. So that presents a lot of challenges that need to be solved in order to take care of those people. Look at the picture on the right. You see traffic flows and transportation. If you've been to some of the larger cities, you probably sat in traffic jams such as this. And as that world population grows, there's going to be even more people on the roads. I remember when I was a kid going into Chicago, all the highways going in were 2 lanes going each way, and you had toll booths. Now when you go to Chicago, those lanes are 4 and 5 lanes wide. So you've already seen a lot of that impact of more population, more people driving. And so engineers are going to take those problems and really work through what it takes to be able to take care of all those people. It's not just transportation, it's food and water. You've got to feed and give them water as well, and then also give them energy to live. So let's talk about that a little bit more. So all these people need food, right? So as we're adding 2 billion people to the world's population, we need more food. And really at John Deere, we really like to see that because growing food and products that allow farmers to make that food is really what we're all about. If you look at the US population alone, that population growth is going to need about 1 million rail cars of corn per year more. That's not just for feeding us, but it's for feeding the animals that we then in turn, the cows, the hogs, the chickens, everything that takes corn to feed more people eventually. So that's a pretty radical growth in the amount of corn production that we're going to be needing over the next 20 years. And again, that's US alone. So what else do we need in order to provide consumption for people? Of course, it's water. Think of an Olympic-sized swimming pool. That's pretty darn big. And in order to provide the water for survival and cleaning that additional population needs, just in the US alone, that's 44,000 Olympic-sized swimming pools per year, more water. So that means more water delivery systems, more water purification systems. All of these problems need to be solved by engineers in order to get that water to people. What else do we need? Energy. Obviously, I'm working from home, if you can't tell. So that means more energy consumption at my house, but that's just one small increase in energy change that we've seen over the last 6 months. If you look out over the next 20 years again, that population growth is going to be a 50% increase in worldwide energy. Energy is what we all need. And if you think about the new gadgets that we're having in our lives all the time, telephones, computers, tablets, we are using more and more energy, and we need energy creation systems and energy transmission systems to pass that energy on to all of us as consumers. Okay, so now I'm going to talk about some of the main types of engineers out there in the world. And the first one is mechanical. And I would say if I look at the people at John Deere, probably about 3/4 of the engineers that we have are mechanical engineers. If you look at the bicycle, think about the gears, the pedals, the sprockets. That's the system that propels that bike. So that's really what mechanical engineers do, is design systems like that to transfer power. This is obviously a racing bike because you see some of the additional features, particularly around the wheels. Think about, if you're racing a bike, you want less drag or less uh, movement that's going to draw against you to slow you down. So if you look at how they've redesigned the wheels to allow for more efficient movement with the additional features, also weight savings. If you look at the front wheel, you don't see spokes around the entire wheel. So that's an engineer looking at how you can design that wheel with the least amount of weight, but giving it the structure that it needs to be successful. The picture on the right is really neat because this is a person with an artificial limb. So if you look at this picture from the knee on down, you see what looks like a metal structure there, a simple metal plate. But it's not just a simple plate. That's got to not only withstand the force of running and the weight of that person, but it's also got to be flexible. So mechanical engineers look at the materials that would need. If you make that out of something that's brittle, it's going to break. So you've got to find materials that are strong enough to hold up that person and stand up to the forces of running, but also be bendable in order to withstand and bend but not break. So that's mechanical engineers. Electrical engineers are something that we should all appreciate more and more as we're having more gadgets come into our lives. Just think in the last 10 years, the gaming systems, the explosive growth in telephones, computers. When I was a kid, we drove in cars that had manual roll-up windows. Now they're all electrical windows. And as you get into your cars, you see more and more cars with GPS systems. That requires electrical systems to transfer those signals and power those signals. In our world, we call them wiring harnesses. So it's the set of wiring, it's the system of wiring that transfers power and signals throughout the vehicles. So electrical engineering is really a field that's seen explosive growth in the last, I would say, the last decade. Next area is industrial engineers, or at John Deere, we call them manufacturing engineers. This is really what my background was out of college. I went to college at the University of Iowa for industrial engineering. But industrial and manufacturing engineers really look at production systems. You can see the picture on the right shows a filling system for milk jugs that's highly automated. The picture on the left shows an assembly. It looks like that's an engine. So really what our industrial or manufacturing engineers do is figure out ways, the most efficient ways and the tools needed to put things together in the most efficient and time-sensitive systems as possible. The next area is civil engineers, and you may be very familiar with what civil engineers do and not know it, but the roads that you ride on every day are designed by civil engineers. Think of that additional traffic flow that we talked about earlier. If you go to Milwaukee, the Marquette and Zoo interchanges have been severely redone in the last few years because of the additional traffic flow that's coming through. So civil engineers design those roadways and structures. The picture on the bottom, I don't know if that's Miller Park, but it sure looks like our roof at Miller Park. So civil engineers would design that structure that it takes to hold that roof together and open and close as well. Finally, the chemical engineers is another very common engineering. Look at the picture on the top. That shows a sprayer out spraying a field. So it's giving that plant fertilizer. It's giving that field a weed control application also. So chemical engineers look at all the elements available to us and what combination of elements that are needed to provide what we need. So for example, we need to be able to provide a fertilizer that allows that plant to grow, but it's also safe for human consumption. Likewise, the bottom picture shows what looks like hand lotion. So again, a chemical engineer would look at all the elements available to provide moisturizer, but not damage to your skin. So that's a little bit about the main types of engineers. There are many other types of engineers out there. I'll highlight one, geological engineering. A family friend of ours is a geological engineer, and she works on the oil fields in Texas, looking at the most efficient ways to draw oil out of the ground. So there's many different types of applications. Biomedical, we talked about the runner with the artificial leg earlier. That's really what biomedical engineers do, is focus on the mechanical aspects and body bracing and artificial limbs to solve a problem for really people that need that extra help in their life. So I will turn it over to Chris to talk about what engineers do specifically at John Deere.
Super, Gary. Thank you. I appreciate it. My name is Chris Bailey. I work in the manufacturing industrial engineering portion of John Deere. My folks that work in my team are the ones who are responsible to put the assembly lines together. So we'll take a walk through how the engineers work all the way through our process, and we'll talk a little bit about how my group helps to work through that. But we're going to look at engineering awareness. So Gary's talked and did a great job of explaining all of the opportunities for engineers. So you folks now are fairly aware of what engineers do. But when we looked for some different data on trying to understand how many people get a chance to see what engineers really do, 95% of the young people that were surveyed said that they were not interested in a future engineering career. And some of the reasons, about 40% didn't know much about engineering. Now, hopefully we've taken care of some of that, or will by the end of the conversation today. 30% didn't think it sounded very exciting. And we can look at some of those things as well. I think there were quite a few examples there for both males and females as far as engineering and what we can do with that. And then 21% said they weren't confident enough in their math or science skills. And engineering may not be for everybody, but if you have some strong desire and curiosity, as Gary mentioned, in how things work, and that you find the time goes by quickly when you're working in math or science, boy, it really is something you probably should take a look at. So a couple of the points here that were interesting to us: 20% of parents surveyed encouraged their children to make engineering a career choice. So only 20%, yet virtually all the parents saw the value in math and science. As you go through your life, whether hopefully you enjoy math and science, but you will see that there is a significant amount of math and science in your life every day. For engineers like myself and others that's here at John Deere, we employ those skills and use those to help make better products that will take care of problems that people have. Some of the other statistics that were interesting to us: boys were 5 times more likely than girls to be interested in engineering. And I think that has something to do with how we are making folks aware of what engineers can do and how they can be interested in that. I have a personal bias here because I have 2 daughters, and they are now in college, and both of them are in engineering. We did spend quite a bit of time. They found some real joy in math and science and have chosen to follow that, one in mechanical and one in chemical. So that's kind of fun for me. And one of the things that was hard for me to read as we put this slide together was girls were 2 times more likely to be encouraged to be actors than to be engineers. And as we just look statistically at the number of career opportunities that are open, there are probably many more engineering opportunities than acting opportunities. So we really want to, the engineers can help to solve problems, but they can also then build a good life for themselves that helps both themselves and the community in pursuing how to fix problems in and around the areas. So what do engineers really do all day? They turn ideas into reality. So if they have a thought or a concept or something, they can actually design a system or fixture or tool that helps to make that process or project become real. Engineers break things. I worked for quite a while in the development area, and we took products, concepts that people had put together, and we took them out in the field and made sure we operated them the way our customers would. And we intentionally, put them in tough situations, and we broke them occasionally. And then we would come back to the drawing board, if you will, and we would have our engineers help us fix them. And for both of those things, they get paid to do that in order to help try and develop that for John Deere as a whole. They turn problems into challenges. So the engineering perspective is that when you see a situation, we can call it a problem, we can call it something that doesn't work the way it should, the engineer kind of reframes that in their mind to look at a challenge. How could I fix that? How could we design something that would take care of that problem for people? Engineers really develop solutions that help people with things that they want to do or need to do. You saw some of the agricultural stuff that Gary alluded to before in growing food and other things. So this is some of what the engineers do. And if you have that passion in math and science, you can do that. This is really something that you can do. So famous company leaders who are engineers. Now, I'm sure we can't do a raise of hands here with this type of virtual meeting, but I'm sure many have heard of Snapchat, or maybe you've even ridden in your parents' General Motors cars, or used an Apple device or a Microsoft device, or used Google. Many of these companies that are out and really, in the industry and leading the industry have engineers as their leaders, because they are taught to be critical thinkers. They are taught to use that data in the math and science to help make good decisions for the business. And then many of these, in all of these cases, in this instance, serve the community and help to fill a gap or a void that was there before. And now they have put together products or services that can help fill those gaps. So that's some of what the engineers do. So I'll give you an idea of what the engineers do here at Horicon. So as Jeff mentioned when he went through the presentation, on your right, we have utility vehicles. You'll see one that's up there in sand. It looks like they're having some fun doing that. We also do a little bit of recreation. And then on the bottom, as the 4-passenger Gator there fords a creek, you can see that rolling through there. And then on the left-hand side, you have some of the riding lawn tractors that we build here. I'll just give you a quick walk through this and how engineers help us do this. So if we go out to the field and our marketing folks take a look at this, they need to understand the technical aspects of the customer's use. How are they going to use it? Are they going to have 4 guys? How much do they weigh? Are they going to drive through a creek? How deep is it? All of those things to make sure that they can design the vehicle that is successful. They take that information back to our design and mechanical and electrical engineers. And those folks sit together, work together, develop a process and product that will do what it needs to do in order to satisfy their customers' needs. And then they take it to our development or our prototype shop, and the engineers there help to build one of those products. And then it goes out to test, and we test it. And that's where we fix things and we break things, right? So we get a chance to go out and make sure that it'll go through the water. And if it doesn't, we have to come back and redesign it. And then once that product is developed to the point to where the engineers are satisfied, yes, this concept will do what the customer asked it to do, and they will be satisfied with this product when they buy it, then they turn it over to a group like mine, the manufacturing engineers, the quality engineers, and the controls engineers. And we take that concept and we figure out how to put it on an assembly line so we can build as many as the customers will need for the year. And we have some of those, like the tractor on the bottom left, that will come off the assembly line about 1 every 70 seconds in our factory. And some of the other ones, the utility vehicles that you see on the right-hand side, may be up to 10 minutes per vehicle. As those come off the assembly lines too. So we have to fully understand how many the customers are going to want, how we anticipate, how large the assembly lines have to be built, all of those things. As we come together with the program, so that when we launch that, we have a program manager who makes sure that we have satisfied the needs of the customer, that we have put together a plan and a process that will build that vehicle on time and for the cost that it needs, and to make sure that the customers are satisfied with that product as they go forward. So that's a little bit about what engineers do here at John Deere in Horicon. We talked briefly about feeding the world and helping to feed the billions of people that we're going to be looking at on the 2 billion increase that Gary mentioned. Up on the upper left is a combine. You may see those. This is about the time for a lot of combining to take place here in and around Wisconsin. So you'll see those actively moving through the fields here in the next few weeks. On the full right-hand side, that is as they're planting for next year, they may be putting seed into the ground with fertilizer and other things to keep those agricultural things coming forward and continuing to make food for us and for all of the people in and around our communities. In the middle, you'll see some yellow equipment. That is John Deere product that is used for making roads and infrastructure, some of the civil engineering things that we talked about before. And on the lower right, you also see a dump truck that is used in building some of those things as well, to move large amounts of earth so we can get the earth in the right place where the civil engineers asked us to put it, so the roadways can then be built to get us from city to city safely and efficiently. And then again on the bottom, this is grain harvesting, and you probably saw that as you were driving through the fields of Wisconsin in the July timeframe. And again, helping us to gather grains and make food for the people that are in and around our communities. So gives you an idea of the people that John Deere touches and the engineer's opportunity. You have an engineering support group that works on each one of those products and fully understands what the customer needs and then builds the product to serve that need. So you get a chance to be able to help address situations or problems, new roads, whatever they are in the community. You get a chance to be passionate about applying your craft and your skill to build a product that can take care of that need for the community that you live in. So with that, I'll turn it over to Bill Holtz, who's going to give us a little bit of an idea of an engineering problem that we could take a look at for an upcoming season.
Thanks for the handoff, Chris. Again, my name is Bill Holtz. I'm a quality engineer. I've been a quality engineer at John Deere for about 9 years now. And quality engineers, they really make sure that the parts that were coming in meet all of our design specifications and do what we want them to do. And we even help solve problems when the parts don't fit right. And prior to becoming a quality engineer at Deere, I worked as a design engineer where I had to solve some pretty complicated engineering problems. So let's take a look at one right now. Think of an engineering problem that if Santa asked you or John Deere to build him a new sleigh to deliver toys, we'd have to use a design process and begin the process of investigating the request for a suitable sleigh to handle this enormous task that is going to happen on Christmas Eve. And we got to report back to Santa with a recommendation of how we can get all these presents delivered on Christmas Eve. So one of the things we do is we take a look at the entire design process. First, you have to get a problem that you want to solve. You need to generate some concepts, develop solutions, construct and test prototypes, and then evaluate those solutions. But really, it's a lot of teamwork. One of the things about working as an engineer, you work in a lot of teams. You need to be an effective communicator. So all this is needed to solve some of these pretty difficult problems that we deal with in our jobs. So first of all, let's define the problem. If you look at the entire world, there's about 2 billion children, which averages about 3.5 kids per household. And let's just say each child, we're going to assume that they would receive a 2-pound toy, and there's approximately 91.8 million homes in the world. And to get all this accomplished, Santa only has about 31 hours to do all this. The next thing we need to do is calculate how much all these toys are going to weigh. So when we do the math and figure it out, it's about 321,300 tons of toys. That excludes Santa. And as we all know, he could be a little on the overweight side. There's all those treats that he eats when he comes down the chimney. But then on land, you got to figure too that a conventional reindeer can pull no more than about 300 pounds. So you can see that reindeer there, he looks a little frazzled and overwhelmed. And then the next step we do is we would want to generate some concepts. So we would need to assume that a flying reindeer could pull about 10 times the normal amount, but we cannot pull 321,300 tons of toys with 8 reindeer. Even if we assume 9, that's definitely not going to be enough. So when we figure it out, we would need about 214,200 reindeer. This would increase our payload, but not even counting the weight of the sleigh, to about 353,430 tons. Just to put that in perspective, that's about 4 times the weight of that Nimitz aircraft carrier that you see in the bottom right-hand corner of this slide. Now let's try and develop a solution. So we figure Santa's got about 31 hours of Christmas to work with, thanks to the time zones, rotation of the Earth, and assuming that he's traveling from east to west, which works out to be about 822.6 visits per second. So Santa's got about 1/1000th of a second to park the sleigh, hop out of the sleigh, go down the chimney, fill all those stockings, distribute the presents under the tree, got to eat those snacks, don't want to leave any of those behind, get back up the chimney and get that sleigh back out moving on to the next house. Next, the fun part is creating that prototype and actually testing it. So that means that Santa's sleigh moving at about 650 miles per second, which is about 3,000 times the speed of sound. Just to put this in perspective, the fastest man-made vehicle on Earth, the Ulysses space probe, moves at a pokey 24.7 miles per second. Now let's go test that concept. If you have 353,000 tons traveling at 650 miles per second, this is going to create just an enormous amount of air resistance. This is going to result in heat buildup with the reindeer in the same fashion as a spacecraft re-entering the Earth's atmosphere. And we've all seen pictures of that. That can get pretty hot. The lead pair of reindeers would have to actually absorb about 14.3 quintillion joules of energy per second each. And this would create just a deafening sonic boom in their wake. Now let's evaluate this solution. Santa, meanwhile, can't forget about him. He would be subjected to centrifugal forces 17,500 times greater than the force of gravity. In simpler terms, 17,500 Gs. A 250-pound Santa, which could be on the slim side, would be pinned to the back of his sleigh by 4,315,015 pounds of force. So our solution would be the recommendation to Santa from John Deere Engineering is that Santa is not going to survive Christmas. Click that button that the electrical engineers have and use Amazon. So thank you, and that's the end of my presentation. Hope you found that entertaining and educational as well.
Awesome, Bill. Thank you very much for that example there. It's definitely an interesting thought that probably a lot of people don't think of when it comes down to problem solving, but it is the way that engineers typically will approach a problem to try to figure out the solution. And as many of you guys had mentioned, engineers are the ones who really creatively come up with some of those solutions to the world's problems. Again, I'd like to thank Mad Rep as well as all the presenters here today for this opportunity to get in front of students. And I believe we are opening it up to questions and answers. Is that right, Adrian?
Absolutely. And again, thanks so much, Jeff, Bill, Gary, and Chris. This has been a very interesting and enlightening conversation. We do have some questions coming in. One right from the chat box. What is the difference between mechanical and industrial engineering? And I know you covered this a little bit, maybe just a concise, brief outline.
Sure. So mechanical engineers are the ones who design the systems that function. So gear drives that transfer power, transmissions, engines, those types of things, suspensions. And an industrial engineer is the one who designs the process. So to understand if we're going to put something together, the industrial engineer looks to see how much time it takes. There are industrial engineers that are used at Disney to understand how people flow in and out of the different attractions that they have there. There are industrial engineers that are used in seating design to make sure that how long people are going to be comfortable in a certain situation. So mechanical really designs the component equipment, and the industrial engineer looks at the element relative to time.
Right. Thank you for that answer. Here's another one. If you could just describe a basic day in the life of an engineer, and I know obviously it's going to be different, but say someone at John Deere, for example.
Sure. So a day in the life, a lot of these will depend a little bit upon which choice you've made. So our design engineers will come in, they will be working on a project, and they will gather together probably in the morning, go through some email to make sure that if they have a product on test or whatever, they will understand any issues that have risen over the evening with their designs. Otherwise, they will get together with a team. They will start to look at the project and understand how their designs are moving along, if they have ordered tooling for those types of products, how the tooling's coming along, how the rest of the project is coming together. So they will gather in and out of meetings. They will meet with people from Gary's group and understand for some of the supplied parts. When you're an engineer and a project engineer, in this case, you would be responsible for making sure that all of the components can come to the factory in the way they're supposed to be used. So Gary's group, we probably have 70% or so of our product that's actually purchased, and his group is significant in helping us understand when we've given a design. So somebody came up with a part or a roller or something like that, we'll then give that to Gary, and his group goes out and makes sure that that design is well understood at a supplier, and then that supplier can come back. I used to work in the seating industry, so we would get information from John Deere on a seat design that they wanted. They would bring that back to us. We would work with that as a supplier and then bring that back to John Deere. So that engineer then is making sure that the supplier in this case would understand the design, make sure that there are no problems for them to be able to build that design, and then build it within the costs that they have given to them. So the engineer is then going through those meetings. He or she then goes through and sees if there are any new problems that they have to work through, and then gets through that during the day. So you spend quite a bit of your day in and out of meetings in team collaboration, I would say, with other engineers and other disciplines, accounting, suppliers, quality, those types of folks. So you have a significant number of points of interaction with teams.
Excellent. Thank you for that. I've got another question from a student. He says, so if I wanted to have a career in cars, I'm guessing designing cars, I would pick mechanical. It's a question.
I can touch on that one because my son had that same challenge a few years ago when he was in high school, and he chose mechanical engineering. He was more interested in airplanes, Wyatt, but he was choosing between mechanical and aerospace engineering. And what mechanical engineering is a very flexible discipline because you can do quite a bit with mechanical engineering. And what it boiled down to him is that he chose mechanical engineering because if he wanted to start in aerospace in working on airplanes, and then if he, say 10 years down the road, he wants to go into automotive, well, mechanical engineering gives you that flexible background to be able to do that. Whereas if he would have chose aerospace engineering, he would have really been focused on aerospace. So mechanical engineering is a great option if you're interested in designing or working with cars.
Yeah, I would agree and echo Gary's comments that mechanical engineering is a very diverse type background. And prior to coming to John Deere, I worked at Harley Davidson and worked with a lot of mechanical engineers that help design motorcycles.
Just to slightly add to that, I think, and I'm not an engineer by education or by trade by any means, but I have talked to a lot of students about it. It's really, what do you like about the thought of engineering, right? So the concepts of engineering, which is solving problems creatively, right? And understanding how the world works. If somebody says, I'm really interested in being in the auto industry, I would ask them, what about the auto industry are you interested in? Are you interested in new product? Are you interested in the manufacturing of auto? Are you interested in the environmental concerns that may come out, right? You ask them those kind of things. Engineering plays parts in all of those. And so you may have somebody says, I'm interested in the design of new cars. Cool. Okay. Mechanical engineering, electrical engineering, right? But you may have some people who are more interested in environmental concerns and emissions and things like that, where that may be more of a chemical engineer or civil engineering. So it's really all about what interests you. And that'll dictate what level of engineering you want to be in.
Thank you, Jeff. And everyone else who's answered here, Gary. The student who asked that question says, that sounds pretty great. So how is engineering going to be or is being affected by AI?
Great question.
We can take some of that. So we have quite a bit of those interactive models already working with some of the different type of robotic mowers that we've made. We also, and they can teach them once the yard is taught, then they can work their way through the process. We're looking at self-guided vehicles probably as well as the auto industry and others, where that artificial intelligence will help to make the vehicles perform more efficiently, but hopefully more safe than even with humans. And I think that's one of the biggest things is the machines don't have the emotion. They make the decisions and can help us in cases where, our response time, or if we're distracted or something like that, can be an impediment. So I think if anything, and I'm towards the end of my career, and it's interesting to me as I look at some of the technology that's coming out, some of the analytics, we're basically in our fourth industrial revolution as far as understanding how much data we get back from the factories and from the field and from the cars that are out there. We can look at the performance indicators and understand how to design them differently and make them more efficient and more effective. So I think the engineering curriculum will only grow because you'll have better data to make better decisions with, based on the fact that the artificial intelligence can grab a lot of that data a lot faster. So in the last few years, I think we saw a metric around 90% of the world's data has been generated in the last 2 or 3 years, which is just amazing. Engineers use data to make decisions. I can see that just growing in their way they participate in the designs with better and better pieces of information.
Excellent.
Yeah, and I'd say as technology is increasing, I mean, it's also increasing the need for engineering competency as well too. So, I've had the question asked, does AI eventually replace jobs or replace it? And it absolutely doesn't. It may change the way we approach it, but if anything, it's just going to give us more data and more opportunity to be able to solve problems more quickly and more efficiently. And I'll give you a case in point. If we were to say, hey, we need to double our production in a production line without adding any more manpower, that is going to be all through engineering and technology, right? So traditionally, in the past, before we got into a high-tech world, you would just basically double your line of what you have now with the people and the processes, and you got twice the product out. Nowadays, it's how do you double it, or how do you increase your efficiency without having to, hire or build another plant. And that is all through technology, data, and engineering. We see that even at our plant. Our biggest line out here, traditionally, probably people hand pushed some of our vehicles down the line at one point in order to get it from one station to another one, where now we actually have robots that move our product from one station to another one, and they're intelligent robots. So you don't have to guide them with a remote control. They know when they're ready to move forward, and they know exactly where they need to go and exactly what they need to do. So if anything, it's going to add more efficiency to our product.
Excellent. Fascinating stuff. Thanks so much again for the John Deere team for participating today. We are out of time, unfortunately, and also thank you to Inspire Sheboygan County for producing this excellent virtual career event.
Thank you. Thanks for the opportunity.
Thank you.
Yep. Thanks for the opportunity, everyone. Bye.